Today, folks, we're going to be reviewing for test 7.1 through 7.4. And when we're all done today, you'll hopefully have this chapter wrapped up in your mind so that you can get ready for this exam. Okay, so let's get preparing. Okay, for this first section here, I want you to point something out. First of all, we did exponential growth and we did exponential decay. Growth is when it increases from left to right. The b value, this b value right there, will be greater than 1 when it's an exponential growth. When it is between 0 and 1, then it's exponential decay. Now, there were times where we dealt with an exponential growth decay that was a percentage. When you have a percentage, you have a constant percent decrease or a constant percent increase. When you had those, you took your rate of increase or decrease and went 1 minus or 1 plus. 1 minus was for decay and 1 plus was for growth. Okay, now let's move on and let's take a look at an example like what you did in your homework. So this problem says a new softball dropped onto a hard surface from a height of 25 inches, rebounds to about 2/5 of the height of each successive bounce. Write a function representing the rebound height for each bounce. Now, first of all, you have to remember, you have a of t equals to a. Now, remember what your a was? Your a was your initial value. So you had a of t, and that is equal to your a value, your initial value. Your initial value here was 25, so you plug in a 25 there, times, and then you had your rebound rate, so it's going to be times 2/5. And that's all going to be raised to your unknown, and we're going to call it x. Okay, so let's see what the answer book, see how it agrees with us here. So let me uncover this little blank, and voila, it agrees with us. Okay, next I want you to pull out your device, and I want you to enter it into your calculator and check it. Look at the graph, that is. Look at the graph. Then after you look at it, I want you to enter some things in there. If you are tracing it, you're going to see the y. Look to see where the y is going to be less than 1. And it turns out it's less than 1, and that is 1 inch, when it's somewhere between 3 and 4. So, in other words, it's going to be less than 1 inch after the 4th bounce. Okay, and that was what we learned in section 7.1. So let's go on to 7.2. In 7.2, we learned how to find the inverse function, and we learned about the domain and range of inverse functions. We also learned about where the range and domain existed and their relationships in regard to the function and its inverse. Okay, so now we're going to start, and we're going to mainly focus right now on how to find an inverse function. When we find an inverse function, remember what you do. Step number 1, you switch the x and the y. And now, when y had an f of x in place, remember you replace the f of x with a y. Okay, then after you did that, after you did step 1, then you solved it for y. And then the last thing you did after you solved it for y, so I could put a step 3 here, you're going to replace y with f inverse of x. And then you had it. Okay, so let's take a look at this first example here that I have here for us, and let's play with this. So first of all, we're going to replace the f of x with a y. Then we're going to switch the x and the y, so I have x is equal to 3y minus a 5 all over 2. And now my goal is to isolate this y. So we want to get it by itself. So in doing that, first thing I need to do is I need to multiply both sides by 2. So that gets rid of this. So I have a 2x is equal to a 3y minus a 5. Next, I need to, let's see, we're still getting this by itself, so I see times and I see subtraction. So I'm going to add a 5 to both sides. And I have on this side a 2x plus a 5 is equal to a 3y. Now I am going to divide everything by 3, and I'm going to divide both sides separately here. So then I will end up getting, and I'm going to flip it over at the same time, I get y is equal to a 2/3 x plus a 5/3. And then the last step, and let's come over here to do it, I will replace my y with f inverse of x. So f inverse of x is equal to 2/3 x plus a 5/3. Okay, and that was how we found the inverse. All right, let's go on to section 7.3. In section 7.3, we learned about logs, and we found that in order for me to find the inverse of a exponential function, I had to find something called a log. So we had to learn about logs. So I needed to know this rule right here. If I have b to the x equals a, I can convert that to this, and that would solve getting the x by itself. And the little saying that I used is the base of the exponent became the base of the log, and inside-outside switch places. Okay, so if I'm looking here, if I have 2 to the 3rd equals 8, the base of this exponent becomes the base of the log, and the 3 was on the inside with the 2. It went on to the outside, and the outside came into the inside. And that's how we ended up with that. Okay, so let's practice a few problems just to review here a little bit. So how did they do this first problem? Well, the base of the exponent becomes the base of the log, inside-outside switch places, so you get x is equal to log of 256 base 6. Looking at this one, now here we're going the other way with it. So the base of the log becomes the base of the exponent. The 4, which is on the outside, comes on the in, and the 624 goes on the outside. All right, now let's take a look at these next situations. But before we can go to these problems right here, let's go up here and take a look at these. We have some properties that we need to review. First of all, the first one says if I have log of b, base b, it equals 1. Okay? And then, of course, if I convert it, I can see right here, this is the conversion to exponential form. And then the second one says if I have log of any base of 1, it is equal to 0. All right, so with that idea, we're going to come down and look at these problems and play with these just a little bit. And we're going to do what's called mental math. So we're going to do it all mentally. Okay, so let's take a look at the first one here. The first one here, it says I am taking the log of 1, and it doesn't matter what the base is. So what's it going to be? Well, using this right here, what is it going to be? 0. That's correct. Okay, now let's go over here. In looking at this problem here, I have log, notice you don't see a base, so it's going to be base 10 of 0.001. Now, that 0.001, remember, is 1 over 1,000. Okay, so let's go up over here and look at it. So it's going to be log base 10 of 1 over 1,000. Now, I can change that to log base 10, and 1,000 is the same as 10 to the negative third. Okay, so again, now this little bit of terminology that I'm going to use right now is nothing formal, it's just my way of saying it. When you have this base of the log, the same as the base of the exponent, these log out, leaving you with just the negative 3. And that is how we got that negative 3. Okay, so let's take a look at another one here. The next one here, notice I see log of 64, base 4. So let's ask ourselves, 4 to the what power is 64? That's one way of saying it. 4 to the what power is 64? We know that 4 to the third equals 64. So let's write it that way. So we have log of 4 to the third, base 4. And remember, these log out, leaving you with 3. And that's how we got 3 for an answer. Okay, now that we've looked at that, let's go to one more problem here found in this section. And it says, use the given value to graph each function. Then graph its inverse. Describe the domain and range of the inverse function. Okay, this is one you guys did in class. It was number 29 in your textbook. So when you did this, the first thing that you had to do was you had to create a chart. So you took it, you had your x and your y, you created a chart, you had -2, -1, 0, 1, 2, and 3. And now then you had to find each of those ranges. So you plugged each of these here in for x. So what I want you to do is pause the video and plug each of these in for x and fill out the rest of this chart. Okay, so now that you've filled out this chart, let's go ahead and put in here what we have. And let me make my pen a little bit smaller here so I can squeeze these in here. Okay, so first of all, for -2, I get 1.5625. For -1, I get 1.25. For 0, I get 1. For 1, I get 0.8. And for 2, I get 0.64. And for 3, I get 0.512. All right, so let's go ahead and see if we can graph that. So in graphing that, let me go 1, 2, 3, 1, 2, 3. And I'm going to go 1, 2, and 1, 2. Okay, so we're going to spread this graph out a little bit here. All right, so here, let's see. So when I'm at -2, I get 1.5. When I'm at -1, I get 1.25. Here I get a 1. Here I get 0.8. Here I get 0.64. And here I get a little bit more. So anyway, remember your asymptote runs right across here. And this graph is getting ever so close, but it doesn't touch the asymptote, and it looks something like that. All right, now let's find the inverse of that now. So to find the inverse, all we're going to do is switch this. So I'm going to write x and y inverse, and so I'm going to put y inverse to show that. And I'm going to get 1.5625 and -2. Then I get 1.25 and -1. Then I get 1 and 0, 0.8 and 1, 0.64 and 2, 0.512 and 3. Alright, so now let's go ahead and go graph that. And I'm going to graph this one in green. So let's see, when I'm at 1.56, I'm at -2. So it's going to be right down there. When I'm at 1.25, I'm going to be at -1, so it's going to be like that. When I'm at 1, I'm at 0. When I'm at 0.8, I'm up at 1. When I'm at 0.64, I'm up at 2. And when I'm at 0.1, I'm up at 3. So anyway, the graph is looking like this. And okay, now, and remember your asymptote this time runs right down there. All right, and doesn't touch it, it just forever becomes closer and closer to it. Okay, so let's see if we've done everything here. It says, find the values, graph the inverse, describe the domain and range. Now, for the domain and range of this, something you need to remember. Your domain is always for these type of functions like we have here, and you can look at the graph and see this. Your domain for the original function is going to be -infinity to +infinity, and your range is going to be 0 to infinity. So that means the inverse of it is going to be flipped over. So if I look, let me just write inverse here. So my domain is going to be from 0 to infinity, and my range is going to be -infinity to infinity. Alright, and this is what it will always look like for these type of functions that we're playing with here, that you're going to see on this exam. Okay guys, this pretty much wraps up this question. Let's go on to the next one. For section 7.4 we had some properties that we learned. Okay, now remember the exponent properties here? We have properties like them for logarithms. It allows us to expand it. Notice right here, and I can expand it. Where it's times, it's add. Just like here, where it was times, it's add. Now, when it's divide, it's subtract. Just like over here, when we were dividing, it was subtraction. And if you have, over here, remember we add a power to a power, so you multiplied them. Well, when you have a p right here, you can pull that p out front, and that p will be times the log. Alright, so that was that one. Now, we also had another formula where, a lot of times I indicated that our calculators can't handle just any old log. Most of them just handle base 10 or base e, and we haven't talked about base e yet. Well, this is a formula where you can change your log into any base using this formula here. So you just take the log of x over the log of b, and you change the a value to whatever log you want. In most of our cases, it's going to be base 10. Alright, so here's an example. You have log of 8, base 4, so it's going to be, now they changed it to base 2, so it's going to be log of 8, base 2, divided by log of 4, base 2. Alright, so let's go ahead and let's play with a few examples here. And look, and now, for the first one here, I just want to compress it. Okay, and the answers are right there for us, so we can check. So, we're just going to compress this here. So in compressing this, and let me change pen colors here. Let's go to a more interesting color. How about, I don't know, some orange, or some purple. So let's try some purple here. Okay, so in trying this one here, notice you have a plus. You see that plus? Plus means times. So it's going to be log base 3 of 3 times 27. And of course 3 times 27 is 84. So then we have to ask ourselves, well, if I have log base 3, 3 to the what power equals 81? Well, it's 3 to the 4th power. And of course this logs out, leaving us with 4, and that's how we receive this answer right there. Alright, so let's go ahead and do another one here. Here I have a subtraction. Okay, so because I have a subtraction, that means division. So and we're going to come right here to work on this one. So I have log. Now notice right here you don't see a base for the log. That means it's base what? Yep, you're right, base 10. So it's going to be log, and I'm going to write 5.4 divided by 0.054. Alright, now, since it's base 10, now we can go ahead and play with this. If you take 5.4 and divide it by 0.054, that is the same as the log of 100. Now, remember this is base 10. So ask yourself, 10 to the what power equals 100? Well, 2. So you can rewrite this. Let me pull this up a little bit more. So you can rewrite this as log of 10, 10 to the 2nd power. This logs out, and what are you left with? A 2. And that's how they got this answer 2 right there. Alright, so let's go to one more problem here and play with this. In looking at this one here, I want you to see we have a 3 up there. You can bring that 3 out front, remember? Okay, so it's going to be 3 times the log base 2 of 16. Now, 2 to the what power is 16? Well, 2 to the 4th power is 16. So it's going to be 3 times the log base 2 of 2 to the 4th, which is 16. Now, remember, these log out, and you're left with just 3 times 4, which is 12. And that's how they got the 12 for an answer. For the very last question, all you're going to do is you're going to use the change of base formula. And you're going to just plug it into your calculator. So for this one here, you have, now we're going to change it to base 10. So log base 10 of 9 divided by log base 10 of 4. And you just enter that into your calculator, and that is how you will get that answer. Okay, so now things you need to know for the test. Make sure you know this formula. Also, make sure you know, as we've gone through, make sure you know each of these. Okay? You need to make sure you have those in memory, along with some of the other formulas throughout these 4 sections. Make sure you know them. Okay, guys, well, that's going to wrap this up for today. Our assignment for next class period, and we're going to do this in class, it's going to be on page 520, and we're going to play with these problems and work them out. Okay, well, good luck studying, and I'll see you in class.